Electric trucks promise cleaner freight, but long routes still mean heavy batteries and charging stops. Engineers have tested overhead wires, conductive rails, and coils hidden beneath pavement. This is the contactless version. The road can carry part of the truck's energy. In Indiana, Purdue and INDOT placed that idea beneath a heavy truck. At 65 miles an hour, the road delivered 190 kilowatts. No plug. No charging stop. Not in a laboratory. What was under that road, and where did the power go inside the truck? A practical system coordinates road and vehicle, energizing the useful segment around its receiver rather than the entire lane. The truck moves almost 29 meters every second. At 65 miles an hour, it would cross an illustrative 4-meter coil zone in about 14/100ths of a second. Detection, control, and power transfer must behave like one fast machine. Now make the road transparent. Alternating current in the transmitter creates an alternating magnetic field. A receiver beneath the truck couples to it across at least 8 inches of ground clearance. Nothing scrapes the road, and energy is not jumping as an arc. The field induces power in the receiver. Vehicle electronics condition it for the truck's DC bus. This resembles a phone charging pad, but the scale is violent. A phone pad may transfer about 15 watts. Indiana delivered 190 kilowatts more than 10,000 times as much while the receiver moved at highway speed. Now comes the part most simple explanations, miss. The DC bus does not belong only to the battery. It also supplies the traction inverter, motor, cooling, controls, and auxiliaries. So the battery sees a power balance, not the headline number. Take power received from the road, subtract conversion losses, subtract propulsion and auxiliary demand. The battery receives only what remains. On level road, the remainder may be positive and the battery charges. During hard acceleration, a climb, or strong drag, demand may exceed received power. The battery then still discharges, but more slowly than without the road. If both sides nearly match, charge can remain almost level. Charging while driving can therefore mean charging, sustaining, or extending range, depending on the instant. Indiana is not the only road-scale demonstration. On a separate 1.5-kilometer section of France's A10 motorway, a truck, van, car, and bus entered real traffic trials. Vinci reported more than 300 kilowatts instantaneously, and more than 200 kilowatts average under optimal steady-state conditions. Those figures belong to France, not Purdue. And the map is getting crowded. DENSO reports a 50-hour continuous drive demonstration without reducing battery charge. Japan's first public road experiment transmitted about 10 kilowatts and replaced 63.3% of the test car's driving energy. After 18 months, researchers reported stable buried coil parameters and no false transmission to ordinary vehicles. In Italy, IVECO announced a road-ready eDaily van with integrated dynamic and static wireless charging entering service with the A35 Brebeni operator. These are different proofs: heavy truck power, public motorway traffic endurance, public road control, and vehicle integration. Together, they show which pieces are real and how much still must connect. Then scale the power. One truck receiving 190 kilowatts is a fast, charger-sized moving load. 10 at that level total 1.9 megawatts. 100 total 19 megawatts. That arithmetic is illustrative, not a forecast, but it exposes the next problem: feeders, converters, segment scheduling, traffic diversity, billing, protection, communications, and the grid must all move with the vehicles. The pavement must survive what electronics avoid: water, temperature, axle loads, vibration, repairs, and years of traffic. Different receivers must align and interoperate. Electromagnetic compatibility and field exposure need testing. Failed segments should not close a corridor. Every energized meter must justify construction and maintenance. Standards work such as SAE J2954/3 matters because a road useful to only one prototype is not yet infrastructure. That is why early deployments may target freight corridors, bus routes, ports, steep climbs, and fixed high-use lanes, not every street. High utilization could justify the road while vehicles carry smaller batteries and stop less often. So, can a highway charge your truck while it drives? Yes. One delivered 190 kilowatts at 65 miles an hour. But this is not unlimited range by magic. It is a choice about where society builds the energy system: in larger batteries carried by every vehicle, or in shared electrical infrastructure beneath selected roads. The power can cross the gap. The future depends on which side of that choice we are willing to build.